Hello, flatties and globe defenders. It's Critical Think from Down Under. And today I'm interviewing a flat earther. Now, this is a pretty unusual guy because he's a flat earther who's willing to admit that he's wrong. Mitchell is a guy from Australia, fellow Aussie, and he's the guy that's behind the Talk the Line experiment. Well, g'day, Mitchell.
How you going, mate? How are you?
Yeah, we're doing fine today. So, tell us a little bit about how you got to think that the Earth is flat.
Yeah, well, I've always kind of been into conspiracy theories since I was young, like aliens and 9/11, that sort of thing. Looking into those things, just had a strong kind of distrust of government and just really any sort of systems, like the educational systems growing up, and now putting my kids through education. You can just see that it's a lot of manipulation and kind of false truths and things that are set as facts that aren't quite true. To do with like even to do with like law enforcement and the medical system, things that the way I say it is people are human. Everyone has human tendencies. It's human nature to sometimes want power and control. I just see that throughout every system. And so when the theory of flat Earth kind of came up, I laughed at it at first and went into it trying to kind of debunk it, as most flat earthers say they do. And I still haven't found any conclusive proof to debunk flat Earth. But in saying that, I'm not 100% on what the physical nature of our world is, but I've found a lot of evidence to point that we may not be living on a globe.
Okay, that's pretty interesting. I know that there are things that in the government that we're not happy with, and I see one of the good things that I really admire you for is actually having an open mind, which, in my experience, is a little bit different from your normal flat earther. So I noted of note you debunked yourself about your street lights under the mirror. So do you want to tell us a little bit about that?
Yeah, that's one of my most recent experiments. It was kind of just a theory at first, and it's still just a theory because I haven't proven it. As you've said, I've debunked my own video, but the theory was using perspective to kind of demonstrate how, as things move away from you, they appear smaller. And I was using street lights along a long street, I think around about 0.6 miles. Not sure what that is in Australian terms, but I was doing it because most flat earthers are American, so I kind of keep to those units. But yeah, there was a series of street lights, and I was using a mirror facing downwards, only a meter off the ground, and that was totally level. And I was looking down the street, and I picked up a reflection on the underside of the mirror from the street lights that were the furthest away. Now, on a traditional model of perspective, this is an impossibility because parallel lines can never intersect. But I was getting some comments saying that it's possible that there was some light being reflected not on the underside of the mirror but on the front edge of the mirror. And so I proceeded to redo my experiment and cover the front edge of the mirror, and I found that I wasn't getting those reflections anymore. So kind of being honest and after seeing that, I couldn't really keep saying that what I said was the truth, because I found out it wasn't. So I put out a video debunking my own video, and I've received some good praise for that, because you don't, probably from both sides, you don't really see people admitting that they've made a mistake and publicly announcing it. But that's what I think sets the good genuine people apart from the deceptive people. Like, if you make a claim and you've found it later to be false, then you need to be honest about it and let people know.
Yes, that's right. It is very unusual. I know a lot of claims that are provably false, but people are generally not willing to admit it. Now, I just said, why did you choose this Talk the Line experiment as opposed to There's many other ways it's possible of determining whether the globe might be flat or not flat. I did say globe. That's a bit of a slip on my part. I should not say that.
Bit of oxymoron.
Yeah.
That's fine, mate.
So the shape of the Earth being flat or globe, you're interested in the outcome. So what made you choose that particular experiment?
Yeah, look, I just see there's so many visual experiments, like optical experiments out there that people are doing with lasers, long distance photography. I've kind of been through those sort of things, and neither side is going to agree on a conclusive outcome. Like there's always going to be refraction or atmospheric conditions or kind of arguments with the calculations of curves. So I was looking for a physical, mechanical experiment to actually kind of measure and show that there is a bulge or lack of it. So this is like I've kind of received good backing on both sides from flat and globe that they would stand behind the results of this if done properly, and that's what I'm looking to do to try and work out all the variables, and I'm in the later stages of putting this experiment together at the moment.
Right. And how far away do you think you are from being able to perform it?
Look, well, it all comes down to the spectra line that I've chosen. It's been crowdfunded, so it doesn't belong to me, and I expect people to kind of put their hand up and do it, repeat it somewhere else for themselves. But what I'm getting at the moment, I've tried and been testing the actual spectra because it's rated. The manufacturer rating is 50 pounds with a breaking strength of 78 pounds, and so I've been trying to test that just to get those forces out of it. But I've only been getting up to 40 pounds on the spectra, so I've been going through my attachment methods, the knots I'm using, the way that I've been tensioning it, and it's kind of come down to using a leading line that's around about 200 pounds, and kind of attaching that past the pinch points and past the points that's going to have the most strain on it for the spectra. And so all the strains on the much stronger line. So in theory, I haven't tested it yet. I'm looking to test it this week. Hopefully I need a consistent reading of over 50 pounds on this line to make this experiment valid.
Yes, I think it is a bit of a challenge, that experiment, because you have to go over such a long distance and the tension and everything. And it is a challenge. And, it's such a small drop over only 2 miles. So I don't know how it's going to turn out, but, I hope it works for you, really.
Well, do you want me to go over the kind of the basics of what's actually happening? It is a small drop, but yeah, do you want me to go into what's going on in the experiment?
Oh, if you like, yeah, that'd be good.
Yeah, okay. So yeah, as you mentioned, it's over 2.1 miles. So over that length, this is totally over water as well, at water level, and that's the key to this because a lot of argument was the basic thing of it is a strong line tensioned over a body of water to measure if there is a curve or not. So the theory is if there is a curve, the line will be tensioned and be forced underneath the bulge of the water in the middle.
Yes.
So yeah, doing it at water level, this line being almost neutrally buoyant, it's got a specific gravity of 0.98, so it is on the buoyant side. So it will be done at water level. And so going through the calculations, and I've had this peer reviewed by a professional engineer on the globe side as well, and he agrees as well that this experiment could be viable. So there's 9 inches of bulge over that 2.1 miles, and so it all depends on the salinity of the water. That's the variable here, and on the day I'll be testing that. So on the kind of less salty end of the scale, being an SG of the water being 1.01, there would be a buoyancy factor of around about 2.5 inches rise. So that's what you'd expect in that sort of salinity. And then what ocean water is about 1.03. So you'd expect that line to be about 4.2 inches buoyant force in the middle. And then if it's up to a higher scale of 1.05 SG, which is pretty salty, it could be up to 6 inches of lift buoyancy in the middle. So there should be a bulge of about 9 inches in the middle. So all of those readings, even if it is on the saltier side, there should be at least between 3 to 6 inches of measurable bulge in the middle.
Right. So it's going to be a little bit tricky because people have said, some people have said like the line will sag, but what you're saying seems to me that it will be more buoyant than and the force will be causing it to rise. Is that what you're saying?
Yes, yeah. I've searched, like, if there is a material that is exactly neutrally buoyant, or kind of on the heavier side, would be better in salt water. But if you were doing this in fresh water, there'll be a lot less of a buoyant force. But the buoyant force will still be a lot less than what the bulge is. So in theory, this experiment should work in the salt lake that I've chosen. And it is a salt lake, so it's a tidally locked body of water. So there shouldn't be any current. But yeah, kind of factors to consider is obviously the wind and temperature. Things are more or less buoyant in warmer or cooler water, but I'm looking to do it over the summer, so the water's a bit warmer. So it's actually less of a buoyant factor. So yeah, I'm trying to approach this from the globe perspective. I'm trying to prove that there is a bulge here. I'm not trying to kind of prove it's flat. So that's the way I'm looking at it at the moment.
Yeah. So what do you think about some of the other ways of determining curve or flat? Like, for instance, the latest rage seems to be measurable horizon drop. So have you had a look at that?
I've seen some videos on that, and yeah, I think, well, for me, yeah, it's a bit hard to actually determine. Like, I've seen Woofy post some videos being in the cockpit and showing there is a horizon drop. Just for me, that I try and keep to things that I can actually prove myself. I can go and prove that, and kind of being in anywhere else that's kind of in the cockpit of a plane, you can't really see it out of a normal passenger window. So, do you see that as a proof of globe, the horizon drop?
Horizon drop, definitely I do. I've got some videos of my own. In particular, I've taken a picture of a ship that's on the horizon that shows that the water does not rise to eye level, for instance. Um, like if the
Okay,
Earth,
so
yeah.
that's from a plane. Sorry, is that from a plane?
No, it's from the ground, and anybody can
Okay.
take this picture. I'll see if I can find it to bring it up. I'll just have to get you to talk on something while I look for it. That's all.
Yeah, that's fine. Yeah, well, another experiment that I have done I think that's the name that should be coming up is Aussie's Flat. That's my first kind of YouTube channel, and I've travelled around a bit, and I did a observation at Ceduna in South Australia. There's an island called Lowndes Island that's about 30 kilometres off the coast of Ceduna. And like, I measured that with Near Maps, not just Google Maps, because Near Maps is a commercially, like, you have to actually pay for this map system, because like I kind of get it through my work, so I can use that, and it's got the data on elevations, and you can zoom right in. You can pretty much read number plates, so it's very very accurate. And so yeah, the Lowndes Island is 30 kilometres out. It's 13 metres high in the water, and I took pictures and videos from 30 kilometres away at an elevation of 8 metres on the shore. So I think I put it into the Metabank metabunk calculator, the Earth curvature calculator, and there should be a bulge of around 17 meters. So to me, like, I shouldn't really be seeing that particular island. And if you later, if you want to go to my YouTube channel, you should see that short video there.
Yeah, I can take a look at that now. I'll see if I can. I don't know whether you can see because you're driving, so I don't know whether you can see the picture.
Yeah, I can see that
And
red line at the top of the
yeah,
ship. Yep.
all right. Now I just got to figure out how to keep this thing on the screen. Oh yeah, I lose it. All right, I've forgotten how to keep it on the screen. I just have to keep talking. That this this ship is around about 32 meters high, and I'm taking this shot from 24 meters up on some headland at Caloundra at Moffat Beach. And I'm saying with this picture that if the Earth were flat, the horizon, the water should keep going out very flat until it looks like it rises to eye level because it just goes off into the distance. But I've drawn the 24-meter line there on the red line, and the water doesn't rise to that level. It drops away before that. So I don't know. What do you think about that?
Okay, I see what you're saying. Yeah, that should be about 24 meters on the ship there, and you're looking from a elevation of 24 meters. So you're saying that the water should rise to your eye level where that red line is.
Yes, that's
Okay.
right.
Okay. Well, yeah, that's totally reasonable, but yeah, it's yeah. Well, I'm not really sure. Like, I haven't really investigated into kind of horizon drop or eye level. Like, I know a lot of flat earthers do say that the horizon should rise to eye level wherever you are. So I suppose that would be a sort of proof for the globe side. I think. Yep.
Yeah. Is it okay if I ask you another question
Yeah.
about?
Sure.
So, in Australia, for instance, a lot of people say that if you're an Australian and you're a flat earther, it's a little bit more difficult because, especially this time of year, the sun rises from south of east and sets south of west, which,
Yep.
if on the flat earth circular model, that's an impossibility. So, have you thought about that?
Well, it depends what your oh, so yeah, as the sun comes around on the azimuthal equidistant map, you're saying that we won't be able to see it on the south side of east. Is that what you're saying?
Yeah,
Because
that's what I'm saying. It's a physical impossibility.
have you looked into east not actually being east on a globe and on a flat Earth map? Not that I subscribe to either. Like, I don't really have a model for the physical world that I live in at the moment. But even if you're on a globe and you're looking directly east and you travel directly east, where you end up is not actually directly east on a globe or on a flat map from where you started. Have you looked into that sort of
Yeah,
thinking?
I have seen a lot of people get confused about that because they can draw a line on Google Earth that starts out as a heading of east, but because of the way that Google Earth works, you don't. Heading east is a constant line of latitude, and if you start to draw a line that's a heading east on Google Earth, yeah, it eventually crosses the equator, and I can explain that, but I've never made a video about it. But when an aeroplane flies due east, they keep their heading due east. That will make sure that they are due east. But let's just say the direction of east is fairly well defined, even at the initial point when the sun comes up in the morning. South of east is a very long way away from north of east in the sky.
Yeah, sure. In your personal perspective of where you're looking, yeah, sure it is. Yeah, using a compass too, and what we have to remember is we get told that there's magnetic declination wherever you are on either map. That we have to kind of, I think it's about 12.5 degrees here where I am. I'm not sure what it would be for you, but it just seems ridiculous where you kind of get down to the more south latitudes, like around Antarctica. There's places that you have to account 180 degrees for the magnetic declination, and that kind of just seems ridiculous. No matter where you kind of, no matter what model you're going off, it just seems such a tool for manipulation and to kind of convert it onto a kind of a flat map for headings and directions and that sort of thing. When you from where you're looking at a physical compass to somewhere that they're telling you you have to account for that much magnetic
Yes.
declination.
Well, I don't take my directions from a compass. I use landmarks and how they look. I look at the map, get the direction off the map for the landmarks, and that's how I get my directions. I don't use a compass at all.
So, how would you determine where north, well, the cardinal points would be if you're not using are using maps that have already set up to like a due north, like a true north, and
Every
you're
map,
using.
every map has a direction of true north and east and west.
Yeah, sure. And so how do they get their north?
It's because, well, I don't know how they make maps. Okay, that's another
Yeah,
thing.
that's
But
yeah.
I know that they're accurate.
Yeah,
And
sure. Like there's never. I don't think there's ever going to be a map made big enough to actually scrutinize long distances. But yeah, all the maps that you can buy that or even kind of zoom in on, they're always going to be accurate, and that's what I'm kind of going through at the moment. This tool that I've just mentioned before, Near Maps. You can zoom right in, and I've been trying to actually map out, like, kind of measure the distance around certain islands, certain continents. It's a long process, but kind of just sorting out whether or not the maps that we're given are correct or not, because there's so many different sorts of maps as well.
it's very easy to check a lot of things on the map yourself because we drive our cars, we use GPS, we can actually measure directions and distances on a map and work out whether they're right or not right. So I have generally have confidence that maps are very well, and there are 100,000 flights a day that rely on maps, and they don't seem to get lost. So I think maps are pretty good.
So you think that flights are relying on maps and not on their own kind of navigation systems?
the The maps are built, as far as I understand. A map is and the navigation systems all have the same data in them, and there's all the data is derived from the globe, really. And if you try, as people have done, tried to map it onto an AE um, map, you get distortions. Like Australia is very distorted on the AE map, for instance.
Yeah, I agree. It is compared to a globe model. It is distorted on the AE map, but who's to say that that's not the true representation of Australia, like on a larger scale?
Yeah, well, that distorted representation is fairly easily to demonstrate that it's would not be the true representation. Um, just by how far you fly, for instance. If you fly from Sydney to Perth, the time it takes, your distance you travel, it's very easy to see that that's not the map, I would think.
Well, the thing that I would have a problem with that is you're not actually in control of that of the speed of that aircraft. So you don't actually know the distance that you are traveling. You can measure on a map, but whether or not the time that it takes um, is kind of consistent with the speed that you're going, because you wouldn't actually know how fast you're going, because it's all kind of inbuilt into the plane. You're not actually controlling the plane yourself, are you?
Oh, that's true. You're not controlling the plane, but for instance, I mean, if I flew from Brisbane to Perth, for instance, I could take with me a GPS logger, for instance, then that would tell me how fast I'm going just by analyzing the data from that.
So, um, and that wouldn't be a constant speed though. You'd be speeding up and slowing down. And have you actually done that and as an experiment to kind of to prove the
No,
distances?
no, but I will be doing it.
Okay, yeah, that'll be a good experiment. I'll be interested to see if it does verify, yeah, kind of the distances they're shown on maps.
Yeah, because you can planes you can not only with that with planes they've got trackers. If you're flying over land, most of the plane's path is able to be tracked through the standard tracking system that they have, ADS B, and you got to pay more to get the satellite version, but you can check for yourself that the planes are flying at particular speeds and places. So I don't know. That's something you could check.
Yeah, well, I recently did check kind of. I was on a plane and I was using my iPad to be in one of those apps that shows where your plane is and other planes are. And although it didn't have cellular coverage, it still had the kind of the GPS system working on it. Um, and when a plane was meant to be going past my position, that's when I saw it as well. So there is, yeah, some validity to the to those apps and to the tracking systems. I'd agree. Yep.
Right. So I know somebody's asked a question in the chat, but we've already talked about your mirror experiment. But there was one thing that maybe people want to know about is that when you say the street lights appear to come down the further distance away they go, but what makes you think that it actually changes the geometry so that if you have something that's 6 foot high and it's level, the street lights are like 30 feet high, for instance, and they're all level? What makes you think that those parallel lines can meet?
No, that's what I'm saying. That
Mm.
that on the traditional perspective model that they cannot meet, but that's not what we appear to see. Like I'm not saying that anything is physically changing, but that's what we appear to see. Like if you look down, like kind of an area of like a if you look down kind of rows of grapevines, they're all parallel, but they appear to you as if they meet off in the distance, like kind of like the train tracks.
Yes,
Um,
that's right.
yes, but
Yeah.
nothing like I'm not saying that anything physically changes. It's just what appears to you as the observer, and that's what I
Yes.
had the problem with the traditional model of perspective, because that um, doesn't take into account the observer's actual perspective. It's more of an orthographic view. It's not from where the observer is viewing, and I think there's, even though I haven't proven um, that theory to be right, it's still, yeah, the theory, as I said before. I think it still um, needs to be repeated over longer distances. Like I was thinking about doing it with a lighthouse in the distance that has a set elevation, and doing it just above sea level from maybe 10 kilometers away. So the curvature of the Earth wouldn't be kind of made as an excuse to seeing the light underneath. But if it did show up, I think that would be quite conclusive to the kind of theory that I'm trying to prove here. I think in the video I did mention that over the distance of the street lights there was a 11-meter elevation from where I was to where the end of the street light was. So I think it needs to be repeated on more of a level ground with the similar elevations at either end, and maybe over a slightly longer distance. And that's what I'll be looking to do. But yeah, I've after that last debunking video, I actually dropped the mirror and smashed it. So I'm looking for a new
Ah,
mirror.
okay. So there's a few things there to think about. It, I'm thinking, all right, just about, is there something that you'd like to ask or talk about at this point?
Yeah, kind of going back to the video that I did mention. Not sure if you probably wouldn't have looked it up yet, but yeah, just seeing that island that I mentioned, like to me, that's kind of proof that I couldn't see any curvature there. There was nothing blocking an island 13 meters high from 30 kilometers away. There should have been a bulge of 17 meters, even if like I was viewing it at 8 meters elevation. I could pretty much see the whole island in entirety. If you want to find that video, or did you find my other channel before?
Your other channel, did you say?
Aussie's Flat. If you just type that into YouTube. But if you didn't want to do that, I can ask other questions.
Yeah, I can look for it now. Just a minute. Oh, there I am again. I've just got to open up a new window.
So this is live. There's a chat that's listening to this at the moment.
Yes,
that I can.
yes,
Okay, well,
that's right.
if a question that to you or anyone in the chat as well that's kind of unrelated to that, but related to flat Earth or globe Earth, something that I've never been able to kind of wrap my head around is how a pressurized system that we live in can kind of exist without a container of sorts. So if
Yes.
anyone has an answer for that in the chat, or if you have an answer, that would help me out for one.
Yeah, so you know that the pressure gradually decreases as the higher you go.
Yeah, sure. I understand that, yep. And obviously it's a kind of a distance, but how is it that we have kind of crosswinds that are traveling faster than the Earth would be traveling, but they're not kind of torn off the Earth into space? Like, how is it that down here at ground level there is a pressure, but it can exist without a container?
Right. So, well, the classical answer is, of course, that the atmosphere is kept to the Earth by gravity. But if you can understand that the pressure gets gradually less as you go higher and higher, eventually the pressure will come out to be nothing. So I don't know whether you can grasp that concept or not.
I can, but I can't see how it would be a constant like this. How it would. So you're saying that gravity holds. Well, your understanding of gravity holds the atmosphere to this spinning ball.
That's right. The force of gravity holds the atmosphere, and there's more pressure down at the bottom because the atmosphere on top of the atmosphere at the bottom get pushed down, and there's more air above, and force of gravity keeps the air attached to the globe, and friction keeps it spinning with the globe. So there's no 1,000-mile-an-hour wind.
No, that's right. There's no 1,000-mile-an-hour wind, but in theory, everything that is moving is going 1,000 miles an hour, and so if we have winds that are traveling west, how is it that the winds can be traveling faster than the actual globe that's spinning itself? Are you saying that friction is causing that?
If a wind is traveling at, say, 100 knots in relation to the Earth,
in the same direction as the Earth spinning.
Yeah, in the same direction. It's 100 knots still in relation to the speed of the Earth. So we all measure all our velocities are only detectable as relative to something else. In terms of absolute velocity, in the terms of rotation of the Earth, yes, the wind is going at 1,000 mile an hour plus 100 knots, but nobody notices it because they're already going at 1,000 miles an hour themselves, and that makes you only experience 100-knot wind. So I'm not really sure what your question is.
Well, what I'm trying to get at is, until we're told we're living on a globe that is spinning, we wouldn't, as you say, experience that spinning. There's no experiment to actually see or feel the motion of the Earth. That's what I'm trying to get at. That all our senses tell us that the Earth is stationary and not moving.
Yes. Do you know how your senses work in terms of detecting movement?
Well, you're about to tell me, I think.
I just want Well, we can only detect acceleration, not absolute movement. So if you're moving in a straight line at 1,000,000 miles an hour, but it's constant, you won't know if there's nothing. If everything around you is moving at that same 1,000,000 miles an hour,
Yeah, sure.
you actually have no experience of any movement.
So yeah, acceleration and deceleration, you would feel it, but if it's constant motion, you wouldn't feel it.
Yeah, so we're effectively constant motion. There's a very, very small acceleration when you're turning, but because of gravity, we're stuck to the earth. We don't notice that. We're just used to it. It happens every day.
So you would say that gravity, like us moving around the sun at whatever speed it is, 60,000 miles an hour, whatever it is. So that from say summer to spring, you've travelled a quarter of the way around the sun. That's a velocity change of kind of 90 degrees that you've experienced over that, and you're saying that gravity negates that force that we should be feeling.
The movement around in 6 months going around the sun is a different movement, but again, it's so minuscule in terms of the scale that we're moving that we don't notice it. The acceleration forces are such that they're very small, and we would not notice them.
Well, yeah, it just seems to me that yeah, it is apparent that we do not notice them. And is there an experiment with other than just what we feel that you know of using instruments that can measure the rotation of the Earth?
Yes, of course. There's a video on my channel actually. The instruments in aircraft that are inertial guidance systems, they're very sensitive, and they are able to detect the Earth's rotation. It's a very interesting video. You should actually see it. So an aircraft has to sit on the ground and align their inertial navigation system, and while it's doing that, it detects the movement of the aircraft in terms of and can measure the latitude that the aircraft is on because of the amount of movement.
Okay, well, I haven't heard of that argument before, but I'll be sure to look at that video.
Now, I got your channel open. Oz is flat. Which video is it you'd like me to look at? That's the 12.8 meters high island 26.
Yeah, that's it.
Yeah, so all right. So I'll see if I can put this up on the screen. Oh, that's the one there. Right.
So yeah, where I'm looking at is Seduna on a kind of a boardwalk, and I don't think it's a very long video, so you can probably play most of it. I
Yeah.
just point out the geographical features compared to near maps. So that's that first kind of bit of land sticking out, and then the last bit of land that is sticking out, and then the it'll pan over to the actual island, Lowndes Island. So that's that final bit of mainland, and that's Lowndes Island.
Yes.
So that's 12.8 meters high
Oh,
at a
I should
distance.
fix it. Yeah.
I think it'll pause it there anyway. So yeah, the observation height 7.9 meters, and should be a bulge of 17 meters in between that 29.6 kilometers.
Yep. Okay. It takes a little while to analyze these things.
Yeah, sure. That's I
So,
don't expect you to have an answer on that straight away, but to me, kind of just looking at that, that's where I'm coming from with not seeing a bulge that we kind of should see over that distance and those heights.
yeah. So I've got many examples of um, similar things where there's much hidden. On my channel, I've got many videos which show hidden places that are hidden.
Yeah, and
So
that's what I kind of talk about with the kind of observational evidence that both sides kind of put up, because like I'm just giving what I've seen here, and again, you shouldn't be able to see that, but you might have a video that proves that there is a bulge. So both sides aren't going to ever kind of come to a conclusive understanding on like those analysis. Like that's why I'm going down the path of the more mechanical, physical measurement of the bulge with my talk to the line experiment.
Yes, so that's your thing. That's pretty good. I think that it's certainly a very interesting experiment, and I hope you can make it work because,
Yeah,
yeah,
well, yeah. What I'd like to ask you about that is, what would you see? You've obviously seen it before today. What problems would you see? Like if I did show it to cut through the water or not cut through the water, the line, what problems would you have with the experiment at the setup?
it's a very difficult thing. It's a very new experiment. Nobody's ever tried it. Um, it has practical difficulties, as I see, simply because of the length of the line and how you, I I guess you may have thought of many of the issues that would come up, but not having tried it myself, I don't really know.
Yeah,
And
it's just one of those things that you kind of figure out that should have already happened but hasn't happened. So yeah, I'm kind of going off whatever I've done. Like I can't really go off anyone else's data because no one else has done it. So I'm starting from scratch here, and I've got a fair way through. Like I'm almost like I haven't got the actual rig in the water yet to see how it's going to kind of go in those conditions of the buoyancy and that sort of thing. But just on land, it looks like it's if I do get the force out of the line that I need, like even if it does cut through the water at all, to me that's a proof that there is a bulge. And if that happens, I'm going to be showing that, and I will definitely I can like I can't really go back to the flat Earth map because there's not meant to be any bulge on water on in that situation.
yes, that's right. Well, that's why I actually hope it will work because
Yeah.
there's definitely curve on water. I can see it all the time.
So yeah, from the figures that I've given you, you can look over that later. Um, if it didn't cut through the water and it did stay above the water, would you say that the water wasn't curving and it was flat, or would there be something else, like another factor that hasn't been thought of? Do you think?
Well, to be honest, because of the enormous amount of evidence that suggests that we live on a globe, I would lean towards thinking there would be another factor involved. That's but if you do it right, I'm sure that it will come out. There'll be a bulge.
And that's what kind of people are expecting. There should be a bulge, but I'm just saying if it comes down to it and there isn't a bulge, um, yeah, what would you think of that? Would you still go back to other evidences of globe, or would you take this as
You
kind
can
of
never take one thing as absolute proof of the shape of the Earth.
no, no, for
Um,
sure.
you need to, there are many, many factors that need to be taken into account, and you can't just take one bit of evidence, and when it's contradicted by 1,000 other pieces of evidence, you can't take that one bit of evidence in preference to 1,000 others. So that's just how the science works. So you got 1,000 to 1 chance of actually being right there. So it's a little bit difficult.
So if we had like just me doing this is not going to prove it proves to me that it might be a bulge or curve, but if other people repeat this, that's what I want to happen to. So that's why I'm being so careful not to snap this line. I want to send this line to other people because there is a couple other people that are looking to do this experiment as well to repeat this, so there can be kind of conclusive evidence and like an objectifiable result that kind of at least proves if there is a bulge or no bulge.
Yes. So it's a one piece of evidence. And you say if you get other people to repeat it and get the same result, that makes it more important. That's just the
Yeah,
way
for
it
sure,
works.
and that's what I'm looking at. So, okay, well, did you want to continue with this discussion, or was
No,
there
I
anything
think
else you want to ask? Or
no, I it's gone about as long as I had planned to. So if there's anything burning that anyone wants to talk about, we can do that. Otherwise, we can we can close this. And I'll just say I'll say before I go there. Look, thanks so much for coming on. It's I admire your courage and your honesty, and I wish you the best with your talk the line experiment. Really.
Yeah, thanks a lot for the support, and yeah, I hope others can look at it and kind of get on board with it. And if there is anyone on around Sydney, south coast of New South Wales that can help out, email me at talktheline@gmail.com. I'm still looking for other volunteers. I've got a few people helping out, but it'll be great to have people on the globe side helping out as well to validate the results, because at the moment it's only kind of just a few flat Earth people that I've got helping out.
Okay.
Yeah.
Well, I hope you do get some people to help out. Somebody wanted me to ask you about how equatorial mounts would work on a flat Earth, but you probably, I don't know whether you know anything about equatorial mounts.
Did you see the piece that Bob did on Globebusters, kind of explaining how they would work on an azimuthal electroresistant map? I think it was one of the last shows that they did. I thought that was a good explanation to how it might be able to work, but not really having too much experience with that. I can't really answer the question myself.
All right, never mind. If you don't know anything about it, just say I don't know. There's nothing wrong with that.
No. No, I'm not going to try and make up an answer as to something I don't know, because that's not being truthful, is it? That's kind of taking a bias, and that's what I'm trying to avoid here. Like I'm just trying to find out the exact physical nature of the Earth, whatever it may be.
Okay, well, I think we can wrap this up. Yeah, I know you have to go soon, and it seems to have come to a logical conclusion. So there, thanks again, and I'll look at your video. I'm actually going to, I'll take this particular video down and clean it up a bit before I put it back up. So if you can't see it, it doesn't matter for now. And I'll look at your video and I'll get back to you about that.
Yeah, no worries, that'd be great. And yeah, thank you a lot for the time and the courtesy of like kind of a fair discussion, and I appreciate that. It's great.
Okay, thanks. We'll see you later.
See you, mate.